So today we went over this problem and tried to solve it, but we never really got a chance to go over the solution. So that's what I'm going to do right now. So the problem says, imagine that your grandmother, uncle, and first cousin are all on a boat that is sinking. Without your help, they have a 25% chance of survival. With your help, they have a 75% chance. By Hamilton's rule, what is the maximum likelihood of drowning you would risk to save your relatives if you wanted to maximize your chance of passing on your genes? Assume that you, your mother, your grandmother, uncle, and first cousins are all expected to have the same number of additional offspring if you/they survive. So for this problem, we're going to use Hamilton's rule, which basically states that the relatedness times the benefit to the recipient of how many offspring they're going to make has to be greater than the cost to you or the altruist in order to save them. So the first thing we want to do to solve this problem is we're going to determine the relatedness of each member of your family. So if we go over here and make like a tree, let's say this is you, these are your parents, that's your grandma, your uncle, and your first cousin. So to determine relatedness, we basically just divide 1 by 2 for how many times we go past another family member. So basically we start at 1 here, go to 1/2, then at your grandma, this would be 1/4. Your uncle, that's also 1/4 because it goes 1/2 to 1/4, and then your cousin is 1/8. So first we're gonna look at case 1, which is where you don't do anything. And the math for that one is that first off, there's only a 25% chance they actually survive. So we're gonna multiply everything by 25% or 1/4, and then we're gonna determine RB. So B for everybody is just gonna be 1 because they're only saving themselves and there's no children, so we don't have to worry about that. And then the R values. So remember, for a grandmother, it's 1/4. Her uncle's 1/4, and then our cousin is 1/8, and that's going to be greater than our cost, which is just 0 because we're not going to die or anything. So when we calculate this, we get 1/4 plus 1/4 is 1/2, plus 1/8 equals 5/8. Times 1/4, multiply that across, we get 5/32. And that's greater than 0. So 5/32 is like the total benefit we'd get. Now, if we did help, then our value for R would be the same as the last one because it's the same relatives. But this time, there's a 3/4 chance of that surviving. So, from last time, that's going to be 5/8, but now multiplied by 3/4 instead, which gives us 15/32. But this time, instead of cost being 0, we have to figure out what it is. And so our cost is going to be a number x times 1. 1 being we have a 100% chance of dying, and then x is just going to be our percent. So like say we have a 60% chance of dying, x is going to be equal to 0.6. And yeah, of course, x times 1 is just going to be equal to x. So what we want to do here is, we know that the benefit for the first option where we don't do anything is 5 over 32. So in order for helping them to be worth it, we want this 15 over 32 benefit minus the cost of what we had to go through to save them to be equal or to be greater than 5 over 32. That way, helping them would be a better option than just leaving them there. So what we can do is we can just take these terms and swap them around. And now we get the equation 15 over 32 minus 5 over 32 is greater than x. So this is just 10 over 32 is greater than x. So then our maximum value would be where x is at 10 over 32. And if we use our calculator to find out what 10 over 32 equals, it's actually exactly 31.25%, which is equal to C. So yeah, that's how you get your answer. Thanks for watching.